Good morning. It is Monday, September 28th, and I'm going to go over the lesson that we did today in algebra. We are working in section 211 called How Does It Grow? And we're looking for the type of growth we have in linear representations. Ideally, what we want to be able to do is go between any of the four representations, the graph, the table, the equation, or the actual situation itself. Today we're going to be working with tile patterns, which we did a lot of last year. So specific questions we're going to work with today. We want to look for how can you see the growth in the tile pattern? What is the starting value for the tile pattern? That's when we have figure 0. And what is the connection to the equation or to the table? So you're going to be given a tile pattern that looks like this. You're going to want to answer the following 5 questions. What do you notice about the pattern? Sketching figure 0 and figure 4. Deciding how much the pattern grows by. Where specifically the tiles are being added. And then how would you predict what figure 100 would look like and how many tiles would be in it? If you can do that, you're going to be able to come up with the equation for letter E. So first one, we're just looking for how is the tile pattern growing. And the easiest way that I think we can do that is if you take a shape, let me lock this again. If you take figure 1, trace it, and then copy it over onto the other shape. And you can kind of see, there we go, where tiles were added. Then I'm going to do the same thing to the next one. Take that shape, drag it on to the next problem. By doing that, you can see this tile was added on the left side on top of that farthest left column. And you have 2 squares added to the column on the far right side. The exact same thing happens going from figure 2 to figure 3. You're adding 1 to the far left column and a stack of 2 to the far right column. So since we know that that's where they're always being added, we can assume that the far left side had this tile added on the left and had a stack of 2 added on the right, which means figure 0 would be the remaining 4 here, which means we have a row of 4 for figure 0. If we want to go to figure 4, that rectangle of 4 is in every shape. So I'm going to draw that first. And then I noticed that in figure 1, there was 1 tile on the left. Figure 2 had a column of 2 on the left. Figure 3 has a column of 3 on the left. I'm going to assume that figure 4 has a column of 4 on the left. So I can draw that up. Do the same thing looking at figure 1. I see a column of 2. Figure 2 has a column of 4. Well, 2 is double 1. 4 is double 2. 3 doubled would be 6, and there were 6 tiles going up. So it appears that the figure number is doubled to get us the column of tiles on the right side. So figure 4 doubled is going to give us 8. 3, 4, 5, 6, 7, 8. And I'm going into the next shape. Based on that, I know that I'm always adding 3 tiles. And I know that the far left side is a stack of tiles, the same as the figure number. So if I want to draw figure 100, I know it's going to be that kind of J-looking type shape that always has 4 tiles in the middle. It's going to have the same number of tiles on the left side in a column as the figure number. So figure 100 is going to have 100 tiles. And on the right side, it's always twice as many as the figure number. So twice as many as 100 is 200. We now know that altogether in figure 100, we have 304 tiles, which brings us to the last step, which is writing our equation. So if I know the number of tiles is going to be y, I won't know that I'm always starting with 4 tiles. And every time I go to the next figure number, I'm adding 3 tiles. I'm going to be adding 3 for every figure number. So if X represents the figure number, I have the total number of tiles. Homework today, after you had done number 1 and then we practiced an additional problem with number 2, the homework was numbers 6 through 8. And we will be continuing this problem again tomorrow. If you have any questions, make sure you log in at 2 o'clock to see either Mr. Copland or myself. Have a good day.